Python 3 Functional Programming. Functional programming is a style of programming that, as the name suggests, is based around functions. The key part of functional programming is higher order functions. We have seen this idea briefly in the previous lesson on functions as objects. Higher order functions take other functions as arguments or return them as results. For example, def apply underscore twice, parentheses func, comma arg, colon, return func, parentheses func, parentheses arg. The second function is def add underscore 5, parentheses x, colon, return x plus 5. Finally, we use the print command, and in parentheses we call apply underscore twice, and in parentheses inside of that we have add 5, which is going to replace func, comma, then we have 10, which is going to replace arg. The result here is 20. The function apply twice takes another function as its argument and calls it twice inside its body. What is the output of this code? Def test parentheses func parentheses func comma arg colon return func parentheses func parentheses arg. So this looks like one of those function calls that are called twice. The next function is def mult parentheses x colon return x times x. Lastly, we use the print command, in which we're going to call the function test, which if you look again at test, it looks like we're going to replace func with a function and we're going to call it twice. So test is going to replace func with mult, and it's going to replace arg with 2. So when we look at mult, we're going to replace x with 2. So we have 2 times 2, which is 4, and now 4 is going to replace x, and 4 times 4 is 16. So the first time we run mult using 2 as the argument, we get 4, which replaces x, and then you run it again, 4 times 4. So our answer should be 16, and it is. Functional programming seeks to use pure functions. Pure functions have no side effects and return a value that depends only on their arguments. This is how functions in math work. For example, the cosine x will, for the same value of x, always return the same result. Below are examples of pure and impure functions. So for the pure function, we have the example def pure underscore function parentheses x comma y colon temp equals x plus 2 times y, and then we return temp divided by, and in parentheses we have 2x plus y. Then we show an example for an impure function, which is sum underscore list equals, and then we have an empty square brackets. So we've created an empty list there. Then after that we have def impure parentheses arg colon sum underscore list dot append parentheses arg. The function above is not pure because it changed the state of sum underscore list. Is this a pure function? Def func parentheses x colon y equals x to the power of 2 and z equals x plus y, return z. I'm going to say yes, and I'm correct. Using pure functions has both advantages and disadvantages. Pure functions are easier to reason about and test. Pure functions are more efficient. Once the function has been evaluated for an input, the result can be stored and referred to the next time the function of that input is needed. reducing the number of times the function is called. This is called memoization. Pure functions are also easier to run in parallel. The main disadvantage of using only pure functions is that they majorly complicate the otherwise simple task of input-output, since this appears to inherently require side effects. They can also be more difficult to write in some situations. So pure functions, a little difficult to write, a little complicated. Which of these is not an advantage of using pure functions? They're easier to analyze, they're easier to write, they're easier to run in parallel. They are not easier to write, so that's not an advantage. Lambdas. Creating a function normally using the def keyword assigns it to a variable automatically. This is different from the creation of other objects, such as strings and integers, which can be created on the fly without assigning them to a variable. The same is possible with functions, provided that they are created using lambda syntax. Functions created this way are known as anonymous. This approach is most commonly used when passing a simple function as an argument to another function. The syntax is shown in the next example and consists of the lambda keyword, followed by a list of arguments, a colon, and the expression to evaluate and return. Okay, so here we have def my_func, parentheses f comma arg, colon, return f, parentheses arg. Then we have my_func, parentheses lambda x, colon, 2 times x, comma 5. Lambda functions get their name from lambda calculus, which is a model of computation invented by Alonzo Church. What are anonymous functions called? Lambdas. Lambda functions aren't as powerful as named functions. They can only do things that require a single expression, usually equivalent to a single line of code. For example, here we have a named function and a lambda, so you can see. For the named function, we have def polynomial, parentheses x, colon, return x to the power of 2 times x times 5 plus 4. And then outside of that, we use the print command, in which, in the parentheses, we call the polynomial function, and we replace the x with a -4 to replace the parameter with a -4 as the argument. Then we show an example of the lambda, in which you're really taking the print command and the expression and putting it in a single statement. So print parentheses, and inside of the outer parentheses we have 2 inner parentheses, the first being lambda x, colon, x to the power of 2 plus 5 times x plus 4. And then we put our -4, which is the argument that replaces the x parameter. The result for both the named function and the lambda are both 0. In the code above, we created an anonymous function on the fly and called it with an argument. Fill in the blanks to create a lambda function that returns the square of its argument and call it for the number 8. So we want to create a lambda function, so we have to start off with the keyword lambda. And we have x, colon, x times x, because we want to return the square of its argument. The argument is x, we want to return the square of it, and we want to call it for the number 8. So we are going to use 8 as the argument to replace the parameter x. Lambda functions can be assigned to variables, and use like normal functions like this. On the right of the equals assignment, we have lambda x colon x times 2. And on the left of that equals, we're giving it a variable. We're assigning that lambda function to a variable called to double. Then we use the print command, and in parentheses, we use that variable, double, and we replace the x with a 7. So lambda x colon x times 2, we're going to replace x with 7, and 7 times 2 is 14. So that's why you can see the result showing 14. However, there is rarely a good reason to do this. It's usually better to define a function with def instead. What is the result of this code? All right, so we have a couple things going on. We have, it looks like we've got 2 lambda expressions. The first lambda expression, x colon x times 3, and that's set to a variable called triple. The second lambda expression, lambda x comma y colon x plus y equals add. And we're going to use the print command, followed by the parentheses, and we have the add variable, and then another set of parentheses with triple 3 comma 4. So let's handle the innermost nesting first, which would be the triple 3 comma 4. What would triple 3 stand for? Well, if we're calling triple and the lambda expression replaces 3 with x, then I'm going to say that triple 3 should be, the value of triple 3 should be 9. 3 times 3 is 9. Okay, so if I'm understanding this correctly, triple 3 will be replaced with a 9, and then when you go outside a little more, we go to add parentheses 9 comma 4. The add variables lambda takes an x and a y parameter, and the expression is that it adds those two together. So if triple 3 is going to equal 9, and then you got the comma and the 4 there, 9 comma 4, add 9 comma 4, 9 plus 4 is 13. So when we go out a little more and we use the print command, we should be printing out 13, if my understanding is correct. And it is. Okay, map and filter. The built-in functions map and filter are very useful higher order functions that operate on lists or similar objects called iterables. The function math takes a function and an iterable as arguments and returns a new iterable with the function applied to each argument. For example, def add underscore 5 parentheses x colon return x plus 5. Okay. After that, we have a list called nums. Nums equals, and in the square brackets, we have 11, 22, 33, 44, 55. So all those are 5 list items. Then we have result equals list parentheses map parentheses add 5 comma nums. Print result. Okay, for each list item in nums, I'm just looking down at the result, and I'm seeing automatically that 11 plus 5 is 16, 22 plus 5 is 27, 33 plus 5 is 38, 44 plus 5 is 49, and 55 plus 5 is 60. So what I'm seeing is that each of those list items are being fed into the add 5 function, and each list item is going to be the argument to replace the parameter of x. So let's read again about how map works. The function map takes a function and an iterable as arguments and returns a new iterable with the function applied to each argument. We could have achieved the same result more easily by using lambda syntax like this. Here we have our list again, nums equals, and then in square brackets the list items, which are 11, 22, 33, 44, and 55. And by using our lambda syntax, we have, you can compare the above line of code with this. Result equals list, so far it's the same. Parentheses map, so far it's the same. And then this is where it's different. Parentheses above we called the function add 5. Here we use the keyword lambda, and this is how the lambda expression replaces the add 5 function. Lambda x colon x plus 5 comma nums. The comma nums is the same in both examples. And then you close up both of the inner and the outer parentheses there. And print result is the same. So if you compare the syntax of both your raw function and your lambda function, you kind of start to get the gist of it. You start to pay attention to the pattern. To convert the result into a list, we use list explicitly. So that's like the same way that you convert anything, any conversion. If you're converting something to string, if you're converting it to int or float, you just tack that on the outside of the parenthesis with the expression, which does the type conversion. So here, again, it says to convert the result into a list, we use the list explicitly to convert it. Fill in the blanks to multiply each item in the list by 2 using lambda syntax. So we have the list called nums equals, and in the square brackets 11, 22, and 33 separated by commas. We want to multiply each item in the list by 2 using lambda. So we have A equals list, because again we want to do a type conversion to make sure that the expression is output in list format, which is the list items inside the square brackets. So A equals list, parentheses map, parentheses, this is going to be a lambda expression, so we want to fill that first area with lambda, x colon x times 2, that's going to be the expression, comma, the name of the list, which is nums. There we go. The function filter filters an iterable by removing items that don't match a predicate. A predicate is a function that returns a Boolean. Okay, let's take a look at this. So we have again a list with the name of nums. Nums equals, and then in square brackets we have each list item, 11, 22, 33, 44, and 55. Then on our second line of code, we are setting what's on the right hand side of the assignment equals to the variable on the left. So the variable on the left is called res, short for result, equals list because we want to make sure that the output is converted to a list data type. And then in parentheses, we start off with the function called filter. Again, the function filter filters the iterable by removing items that don't match a predicate, that don't match the function that returns a Boolean. All right, so we're using the filter, and then inside of the parentheses after that, we have the lambda expression, lambda x colon x modulo 2 equals 0. So if it does not match that as a true statement, as a true condition, which basically wants you to have x be a value that when divided by 2, it has a 0 remainder. And what we're using is the nums list to get those values. Now, 11 divided by 2 does not give you a 0 remainder, so 11 gets filtered out. 22, when divided by 2, does give you 0 remainder, so 22 does fit that constraint, if you will. 33 divided by 2 does not give you 0 remainder, so that gets filtered out. 44 divided by 2 does give you a 0 remainder, so 44 remains. And 55 divided by 2 does not give you a 0 remainder, so 55 is filtered out. So based on that lambda expression and using the filter function and using the list as a data type conversion, we get the output of a list with 2 list items of 22 and 44. Like map, the result has to be explicitly converted to a list if you want to print it. Fill in the blanks to remove all items that are greater than 4 from the list. So we have a list with a name of nums. Nums equals, and in square brackets, 1, 2, 5, 8, 3, 0, and 7. Those are the list items. On the left-hand side of the equals, we have a variable that everything on the right gets assigned to. So res, short for result, equals list. List again because we want the output to be in list data type form. We want to remove items that do not fit the lambda expression, so we want to use filter, the filter keyword that we just learned about. And inside of the innermost parentheses, we have the lambda expression, lambda x colon x greater than 5. We want to remove all items that are greater than 4. Oh no, we want to remove all items that are greater than 4. So if we have x greater than 5, that will not remove 7 because x greater than 5 is true statement. We want to remove things that are not true, so I messed that up. I want x less than 5. Because anything that replaces x that is less than 5 will be removed. Wait, I think I'm confusing myself. Fill in the blanks to remove all items that are greater than 4 from the list. So filter is going to take out what's false. X less than 5. Is 1 less than 5? No, so 1 will remain. Is 2 less than 5? No. Yes. I'm sorry, is 1 less than 5? Yes. Yeah, that 1 will remain. Is 2 less than 5? Yes, 2 will remain. Is 5 less than 5? No, 5 will be removed, which happens to be greater than 4. Is 8 less than 5? No. 8 will be removed. Again, 8 is greater than 4. Is 3 less than 5? Yes. 3 will stay. Is 0 less than 5? Yes. 0 will stay. Is 7 less than 5? No. 7 will be removed. So by using that lambda expression, lambda x colon x less than 5, anything greater than 4 from that list will be removed. And so that's the lambda expression. With after the comma, we have to put the name of the list that we are dealing with, which is nums. And then finally, we print the name of that variable that holds on to all that stuff on the right, which is res, short for result. There we go. Okay, now let's look at something called generators. Generators are a type of iterable, like lists or tuples. Unlike lists, they don't allow indexing with arbitrary indices, but they can still be iterated through with for loops. They can be created using functions and the yield statement. So yield is something new. Here's our example. We have the function def countdown, and we have no parameters, so there's nothing in the parentheses, colon. We set I equal to 5, and while I is greater than 0, colon, we will yield 1. I'm sorry, we will yield I. While I is greater than 0, colon, yield I. Afterwards, we decrement I by the statement I less than equals 1. So I starts off as 5. It does the while loop, and then it decrements 5 to 4. Then we have the for loop that says for I in countdown, print I. Okay. So here we have the result being 5, 4, 3, 2, and 1. The yield statement is used to define a generator, replacing the return of a function to provide a result to its caller without destroying local variables. What statement is used in functions to turn them into generators? Well, the new word that I just learned was yield. Due to the fact that they yield one item at a time, generators don't have the memory restriction of lists. In fact, they can be infinite. Here we show def infinite underscore sevens, empty parentheses, colon, while true, colon, yield 7. While true is that loop that goes on forever unless you have it break out for some reason. For I in infinite underscore sevens, empty parentheses and colon, print I, and your result is an infinite list of sevens. In short, generators allow you to declare a function that behaves like an iterator. For example, it can be used in a for loop. Fill in the blanks to create a prime number generator that yields all prime numbers in a loop. Consider having an is underscore prime function already defined. Let me go back and take a peek. So we use the def keyword for define. Def get underscore primes, empty parentheses, colon, num equals 2, while true, if is prime, parentheses num, colon, yield num plus equals 1. So then num is going to go from 2, it's going to increment up to 3. And it's going to keep doing this over and over. Finite generators can be converted into lists by passing them as arguments to the list function, like this. Def numbers, parentheses, x colon, for I in range, parentheses, x colon. If I modulo 2 is equal to 0, colon, yield I. So if I is an even number there. Outside of that function, we have print, parentheses, list, because we want to convert it to a list output, parentheses, numbers. We are calling the numbers function right now. And parentheses 11, which means 11 is the argument that we are replacing x with. So for I in range x, which we have determined is 11, range 11, range parentheses 11 means 0 through 10, because it's not including that, it's not including 11. It goes up to 11 but does not include. So we have the range of 0 to 10. If 0 divided by 2, if 0 modulo 2 equals 0, which means if 0 divided by 2 gives you no remainder, then yield I, which starts off as 0. Then when we print list numbers 11, the first thing in the list is 0. 1 is the next, between 0 and 10, 1 is the next iteration. 1 is the next list item, if you will. 1 divided by 2 does not give you a 0 remainder, so we do not yield it. So it doesn't get printed out in the output list. 3 divided by 2, 3 modulus 2 is not even. It does not give you a 0 remainder, so we don't yield that either. So we don't yield 1. We don't yield, well, 2 divided by 2 does give us that, so you see 2 is the next. 3 does not. 3 is not evenly divisible by 2, so that gets ignored. 4 divided by 2 is even. It does have no remainder. And so on and so forth, all the way to 10. So it only outputs the even numbers. Using generators results in improved performance, which is the result of the lazy on-demand generation of values, which translates to lower memory usage. Furthermore, we do not need to wait until all the elements have been generated before we start to use them. What is the result of this code? Def make underscore word, no parameters, colon, word equals, empty string, nothing in the double quotes, for ch in spam, colon, word plus equals ch, yield word. Print, parentheses, list, parentheses, make underscore word. Okay, let's see. So because we have print, parentheses, list, our output is going to be in a list format. So the very last possibility will not be possible because we have to see an output that's in list format, which is enclosed in the straight brackets. Make word is getting called. Let's go back up to the make word function, which word starts off as an empty string. For ch in spam, I don't see, well, ch is just the variable that could be anything. It could be I in spam. It could be for x in spam. Word plus equals ch. Word starts off as Oh, goodness sakes. Word starts off as nothing. I want to think that the CH is the iterations of the letters in spam. So I'm thinking it's like short for character. I think for CH in spam is short for character, which could be represented by anything, an X, an I, or anything else. Word plus equals CH, which would be the first character. So word has got an empty string plus the S. Then you yield it, which is just S. Then the next one is P. So word plus equals the additional character, which is the P. So I'm going to guess that the output is the first one showing. S, then SP, then SPA, then SPAM. That feels right to me, and it is. All right, decorators. Decorators provide a way to modify functions using other functions. This is ideal when you need to extend the functionality of functions that you don't want to modify. For example, def decor parentheses func colon def wrap empty parentheses colon print, and then you have this string of equal symbols just to make a dashed line. Afterward, you just have that func, after which you have print, another set of dashed lines, after which you have return wrap. Then you have def print underscore text, empty parentheses, colon, and print the string hello world. Okay. On the right-hand side of the equal, you call decor, and then you replace the decor parameter func with the argument print underscore text, which is the second function, which prints hello world. And then you have decorated. Then you just, I'm just getting confused, but then let me read. We defined a function named decor that has a single parameter func. Inside decor, we defined a nested function named wrap. The wrap function will print a string, then call func and print another string. The decor function returns the wrap function as its result. We could say that the variable decorated is a decorated version of print underscore text. It's print underscore text plus something. In fact, if we wrote a useful decorator, we might want to replace print underscore text with the decorated version altogether, so we always got our plus something version of print underscore text. This is done by reassigning the variable that contains our function. So here we have print underscore text equals decor, parentheses print underscore text, and then on the next line, print underscore text with nothing in the parentheses. Now, print text corresponds to our decorated version. What are decorators? Functions that modify other functions? Yep. In our previous example, we decorated our function by replacing the variable containing the function with a wrapped version. Def print underscore text, empty parentheses colon, print the string hello world. Print underscore text equals decor, parentheses print underscore text. This pattern can be used at any time to wrap any function. Python provides support to wrap a function in a decorator by prepending the function definition with the decorator name and the @ symbol. If we are defining a function, we can decorate it with the @ symbol like this: @decor, def print underscore text, empty parentheses, colon, print the string hello world. This will have the same result as the above code. A single function can have multiple decorators. Which statement can be used to achieve the same behavior as my underscore func equals my underscore dec, parentheses, my underscore func. I believe it's this one, at my underscore dec. Okay, we have recursion next. Recursion is a very important concept in functional programming. The fundamental part of recursion is self-reference, functions calling themselves. It is used to solve problems that can be broken up into easier subproblems of the same type. A classic example of a function that is implemented recursively is the factorial function, which finds the product of all positive integers below a specified number. For example, 5 with an exclamation point means 5 factorial, which means 5 times 4 times 3 times 2 times 1, which is 120. To implement this recursively, notice that 5 exclamation equals 5 times 4 exclamation, comma 4 exclamation equals 4 times 3 exclamation, comma 3 exclamation equals 3 times 2 exclamation, and so on. So generally speaking, n exclamation equals n times, and then in parentheses, n minus 1 exclamation. Furthermore, 1 exclamation equals 1. This is known as the base case, as it can be calculated without performing any more factorials. Below is a recursive implementation of the factorial function. Def factorial parentheses x colon. If x double equals 1 colon, return 1. Else colon, return x times factorial parentheses x minus 1. Outside of that function, we use the print command, print parentheses factorial parentheses 5, and the 5 is replacing the x. The 5 is the argument to the factorial's parameter x. The result is 120. The base case acts as the exit condition of the recursion. What is the base case of a recursive function? A case involving the number 1, a case that never occurs, a case that doesn't involve any further calls to that function. It's the last one. Recursive functions can be infinite, just like infinite while loops. These often occur when you forget to implement the base case. Below is an incorrect version of the factorial function. It has no base case, so it runs until the interpreter runs out of memory and crashes. So here we have def factorial parentheses x colon, return x times factorial parentheses x minus 1. And then lastly, we have print parentheses factorial parentheses 5. Your result for this is runtime error colon maximum recursion depth exceeded. What is the result of this code? Def sum underscore 2 parentheses x colon, return x plus sum underscore 2 parentheses x minus 1, print parentheses sum 2 parentheses 5. Runtime error. Recursion can also be indirect. One function can call a second, which calls the first, which calls the second, and so on. This can occur with any number of functions. Okay, so here we have def is underscore even parentheses x colon. If x double equals 0 colon, return true. Else colon, return is underscore odd parentheses x minus 1. So here, our is even function, if x is 0, you will return true. Otherwise, you will call a function. You will return calling this is odd function, which after the is even function, you see it created. Def is underscore odd parentheses x colon, return not is underscore even parentheses x. We have two print commands. The first one, print parentheses is underscore odd parentheses 17, and Then we have print parentheses is underscore even parentheses 23. What is the result of this code? Def fib parentheses x colon. If x is double equals 0 or x double equals 1, colon return 1. Else return fib parentheses x minus 1 plus fib parentheses x minus 2. Okay, so there's our fib function. Outside of the function, we use the print command, in which we will call fib, and we will replace x with 4. So with x being 4, we have this condition: if x is equal to 0 or x is equal to 1, which 4 is neither 0 or 1, so we will not return 1, else we will return fib. We're going to actually return calling this a couple of times, calling itself a couple of times, fib with the x minus 1, which is 4, minus 1, which is 3, return fib 3 plus fib 4 minus 2, which is 2. Return fib 3 plus fib 2. Fib 3 I need a hint for this because I'm getting tired. Fib 3 plus fib 2 Well, 3 plus 2 is 5, but I didn't know how much back and forth we were going to be calling that, so I'm just going to go with it and move on. All right, I can study this more. I just want to get through this video. Sets. Sets are data structures similar to lists or dictionaries. They are created using curly braces or the set function. They share some functionality with lists, such as the use of in to check whether they contain a particular item. So here we have similar to lists or dictionaries, num underscore set equals, and like a dictionary, we have the curly braces, 1, 2, 3, 4, 5 inside. Then we have word underscore set equals set, and in parentheses, we actually have a list enclosed in straight brackets, and the list items are strings, spam, eggs, and sausage. So then we have print, parentheses, 3 in num set. Well, if you look at num set, is there a 3 in it? Yes, there is. So that is going to be true. And then when you have print spam not in word set, well, the string spam is in word set, so that would be false. To create an empty set, you must use set parentheses as empty curly braces. You must use set parentheses as empty curly braces creates an empty dictionary. Okay, so even though if you're creating a set, a named set that's not empty, you use the curly braces, but if it's an empty, you have to use parentheses. Otherwise, using empty curly braces is creating an empty dictionary. And remember, dictionaries are key value pairs. Sets aren't key value pairs. It's not something colon something. It's just like a list. All right. What is the output of this code? Letters equals the string A, the string B, the string C, and the string D. If E not in letters, well, E is not in letters, so that's true. And because that's true, we're going to print 1. Else print 2. Well, we're printing 1. Sets differ from lists in several ways, but share several list operations such as len, which is short for length. They are unordered, which means that they can't be indexed. They cannot contain duplicate elements. Due to the way that they're stored, it's faster to check whether an item is part of a set rather than part of a list. Instead of using append to add to a set, use add. The method remove removes a specific element from a set, and pop removes an arbitrary element. Okay, so here we have this set called nums, and inside of the curly braces, and again, remember the curly braces we learned before establish dictionaries. So you know that this is a set because there's no key value pair inside of the curly braces. There's no colons used. So, you know, you might initially think it's a dictionary. Oh, no, it can't be a dictionary because there's no colons for a key value pair, so this must be a set. Therefore, when you realize it's a set, then you realize the rules that go with being a set. So we have a set called nums. 1, 2, 1, 3, 1, 4, 5, 6 are the things in the set. Then we want to print nums. And as you can see, 1, 2, 3, 4, 5, 6 is the output because the output of the sets cannot contain duplicate elements. So anything that was a duplicate, like the ones, for example, are not showing the multiple ones. It's just showing 1, 2, 3, 4, 5, and 6. Then we have nums.add -7 and nums.remove a 3. Then when you print the set called nums, you get the -7 tacked onto the end and the 3 simply removed. So instead of 1, 2, 3, 4, 5, 6, you have 1, 2, 4, 5, 6, and then that -7 is added on. Because basic uses of sets include membership testing and the elimination of duplicate entries. Fill in the blanks to create a set. Add the letter Z to it and print its length. Okay, so again, we're dealing with sets. Like dictionaries, they use the curly braces to enclose the contents. So let's set this to our curly braces, which nests the contents. Then we want to add the letter Z to it, so we have nums.add Z, the string Z, and then we want to print its length, so print parentheses len gives us the length. And what is it that we want the length of? We want the length of the set called nums. So print parenthesis length len parenthesis nums. Sets can be combined using mathematical operations. The union operator, which looks like the pipe symbol, that straight line there, combines two sets to form a new one containing items in either. The intersection operator, it's that and symbol, gets items only in both. The difference operator, which is that dash there, that minus sign, gets items in the first set, but not in the second. And the symmetric difference operator, which is that caret symbol, gets items in either set, but not both. So, to test that out, we have a set, 1, 2, 3, 4, 5, 6, in curly braces, set to the variable first. We have another set, in curly braces, 4, 5, 6, 7, 8, and 9, set to the variable second. So the first set's named first, the second set is named second. Then we print first, there's that pipe symbol, which means union, first, union second, which is combining both sets to form a new one. 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the output for the union symbol. print first and second, that only gives us the output of items that are in both lists. If it's not in both lists, it is not going to be part of that set. So the second result is a set that has 4, 5, and 6, because 4 is in both lists, 5's in both lists. 4 is in both sets, 5's in both sets, and 6 is in both sets. The third, print, and in parentheses first minus second, that's the difference operator. It is only going to give us items in the first set, but not in the second. So as you can see, first minus second only gives us 1, 2, 3, because 1, 2, 3 is in the first set, but 4, 5, 6 is included in the second set. We don't want duplicates of both sets, so it's only giving us 1, 2, and 3 in that output. All right, the fourth print command, print parentheses second minus first, is doing the same thing that the one previously did, but now it is going off the second one. So the second one shows 8, 9, and 7. It's not including 4, 5, and 6 because 4, 5, and 6 is in the first. And remember, these are not in any type of order. Okay, the last print command says print first caret second, and that is the symmetric difference operator, which will get items that are in either but not items that are in both. So 1, 2, and 3 is in the first but not the second. 7, 8, and 9 is in the second but not the first. 4, 5, and 6 is in both, so 4, 5, and 6 is omitted. It's filtered out. What is the output of this code? A equals the set 1, 2, and 3. B equals the set 0, 3, 4, and 5. Print A and B. So we want to only print those items which are in both sets, which would only be a number 3. Only 3 is in both sets. Data structures. As we have seen in the previous lessons, Python supports the following data structures: lists, dictionaries, tuples, and sets. When to use a dictionary. Use a dictionary when you need logical association between key, value pair. When you need fast lookup for your data based on a custom key, and when your data is being constantly modified. Remember, dictionaries are mutable. So you do modify things in dictionaries. When to use the other types. You use lists if you have a collection of data that does not need random access. Try to choose lists when you need a simple, iterable collection that is modified frequently. And that is the key word, iterable and modified. Dictionaries are mutable, they're modified. Lists are modified. Use a set if you need uniqueness for the elements, and use tuples when your data cannot change. Many times a tuple is used in combination with a dictionary. For example, a tuple might represent a key because it's immutable. Again, not changeable. Which of the following data types does not allow duplicate values? Sets. Now we are going over something called Itertools. The module Itertools is a standard library that contains several functions that are useful in functional programming. One type of function it produces is infinite iterators. The function counts up infinitely from a value. The function cycle infinitely iterates through an iterable, for instance, a list or a string. The function repeat repeats an object either infinitely or a specific number of times. So for example, we have from Itertools import count. Then we have a for loop here for I in count parentheses 3 colon print I. If I is greater than or equal to 11 colon break. Our result here is starting with starting with 3, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Once I became equal to, greater than or equal to 11, it stopped. Fill in the blank to import the cycle function from the Itertools module. I need to go back and look. From Itertools import count. Okay, so from Itertools import cycle. We want to import the cycle. There are many functions in Itertools that operate on iterables in a similar way to map and filter. For some examples would be take while, which takes items from an iterable while a predicate function remains true. Then there's chain, which combines several iterables into a long one. And there's accumulate, which returns a running total of values in an iterable. For example, from Itertools import accumulate, comma, take while. Here we have on the right hand side of the equals assignment symbol, we have list because we want our output to be in list data type. After which we have in parentheses accumulate, which is the function that we are going to use on range 8. Range 8 is from 0 to 7 because it's from 0 to 8 but not including 8. So we are outputting a list from 0 to 7, but accumulate means we are returning a running total of values. So let's see how that works. How does that work? Returning a running total of values. Starting with 0. 0 plus 1 is 1. Then, let's see, without writing this down. 0 plus 1 is 1. 1 plus 2 is 3. 1 plus 2 is 3. 2 plus... Wait. 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. Okay, just had to get my ball rolling there. That's how that accumulate worked. And that's how we got that list for nums. Okay, so now let's look at the last print command where we have print. In parentheses, we again have list because we want the output to be in list form. Then we're going to use the function take while, and again, take while takes items from an iterable while the predicate remains true. So we will only have included, this is going to be like the opposite of filter. When we are not filtering out, we are adding as long as the expression is true to the list. So takes items from an iterable while a predicate function remains true. So print, list, take while, and in the inner nest we have the lambda function, which is x colon is, and here's the predicate, x less than or equal to 6. So we will only have in the list those numbers which are less than or equal to 6 of the list called nums. Now we printed out the nums list in the first line. So those are the items that we are going to be comparing to the lambda expression and deciding if they're going to be in this second list. So the original list 0, 1, 3, 6, 10, 15, 21, and 28 have to satisfy x less than or equal to 6. 0 is equal or is less than or equal to 6, so that gets included. 1 is less than or equal to 6, that gets included. 3 is less than or equal to 6, that gets included. 6 is less than or equal to 6, that gets included. 10 does not get included. 15, 21, and 28. Those do not satisfy the lambda expression with a true result, so they do not, they're not included. So the take while is like the opposite of filter. Okay, fill in the blanks to take the numbers from the list while they're even. So that gives you a hint. We're going to use the take while. Take the numbers from the list while they're even using the take while function. From Itertools, I gotta look back. I gotta get import. That's what I needed. From Itertools, import take while. Okay, and here's our initial list. Nums equals, being a list, it's in straight brackets, so 2, 4, 6, 7, 9, and 8. Now we want to fill in the blanks to take the numbers from the list while they're even using the take while function. A equals take while. Take while is our key function here. Take while. And take while what? Well, inside of the parentheses here, I see something that reminds me of a lambda function, so I'm going to now use the lambda keyword. Lambda x colon x modulo 2 equals 0. So that statement is referring to even numbers. We have to be able to divide the number by 2 and get a 0 remainder. And then we want to take that, we want to compare the list items that belong to the list called nums. So then we use the print command, and then in parentheses we use the list function of the variable a. A is set to the take while function with the lambda expression of the nums list. Okay. There are also several combinatoric functions in Itertools, such as product and permutation. These are used when you want to accomplish a task with all possible combinations of some items. For example, from Itertools, import product, permutations. Here we have not a set, what is it when it's just parentheses? Here we have a tuple. Tuples are created with parentheses, which means they cannot be changed. So the letter capital A and the letter capital B cannot be changed. So the tuple is letters. Letters equals A and B in parentheses. Print, parentheses, list, parentheses, product, parentheses, letters, comma, range, parentheses 2. Range 2 means 0 to 2, not including 2, so the range is just 0 and 1. The letters are only A and B. The numbers are only 0 and 1. So we get our first list here, and it's a list, so it has to be in square brackets. And we're dealing with A's and 0 and 1 and B's and 0 and 1. So we have A comma 0, A comma 1, B comma 0, B comma 1. Then we have print, parenthesis, list, parentheses, permutation, parenthesis, letters. So now you want to see A comma B or B comma A. Okay. What is the output of this code? From Itertools import product. And here we have, initially we learned about curly braces referring to dictionaries, but we don't have colons here, so we're not looking at key value pairs. So it is not a dictionary. It is not a list. It's not in square brackets. It's not in parentheses. It's not a tuple. It is, what's the last thing that we learned about? It's a set. Okay. And so A is equal to the set 1, 2. We are going to print the length of a list using the function product in range 0 to 2, revolving around the set with the name of A. Okay, so good Lord, what do we got here? Product. We have the numbers are going to be 0, 1, and 2. The numbers are going to be 0, 1, and 2. The 0, 1, and 2 is going to be arranged with a 1 or a 2. Wow. Let me get a hint. I'm tired. The correct answer is 6, and I'll have to play with this a little more. I'll have to look at this a little more to get this in my head. Anyway, we're ready for a quiz. What is the result of this code? We have a set, nums, a set called nums, 1, 2, 3, 4, 5, 6. Then we have nums being set to 0, 1, 2, 3 and symbol, which means that information that belongs to both 1, 2, 3, 4, 5, 6 and 0, 1, 2, 3. 1, 2, 3 is the common denominator for both of those lists. So now nums has the value of only 1, 2, and 3. Now we want to take that 1, 2, and 3, and we want to use the filter function. We are going to filter it with a lambda expression, which means if it does not match the lambda expression with truthfulness, if it's false, that's what we're going to output. Filter is taking what is not matching the lambda expression. So of nums being only 1, 2, and 3, x has to be greater than 1. So 1 is excluded. 2 and 3 are true for the lambda expression. 1 is false, and since we're using filter, we want to grab the 1. Okay, so then we're going to print the length of the list of nums. Our new output of nums should be the value of 1 only, so the length of 1 only should be 1. So if my logic is right, this should be right, and I'm wrong. Great. Oh, brother. Okay. I guess I have to go with the hint. How did we get 2? Let's see. How did I mess up? Nums originally is 1, 2, 3, 4, 5, and 6. Then we took a new list, 0, 1, 2, 3, we use the AND symbol with the 1, 2, 3, 4, 5, 6, which should give us only those items that belonged to both sets, which should have been 1, 2, and 3. So now nums should have the value of 1, 2, and 3. We want to use filter, so we want to take out of 1, 2, and 3 only what's greater. Maybe I'm wrong. Maybe I am not taking what's of 1, 2, and 3. 1 is not greater than 1. 2 is greater than 1, and 3 is greater than 1. So 2 and 3 are true. They match the lambda expression. Maybe I am misunderstanding. I thought filter was picking out what was false. Which would only be the 1. But if I'm printing out the length of the nums list, the only way it could possibly be 2 is if I'm grabbing the true the items that make the lambda expression true, which would be the 2 and the 3, because the length would then give us an output of 2. So yeah, I got to study this more. What is the result of this code? Def power parentheses x comma y. If y is 0, then return 1. Else return x times power of x comma y minus 1. Okay, God. All right, so outside of that function, we use the print command, in which after the parenthesis we call the power function. We are going to replace the x and y with 2 and 3. 2 represents x, 3 represents y. If y is equal to 0, which it's not, y is represented by 3, then return 1. So since that's not true, we're going to go to the else, which returns x, which is represented by 2, times power. God, I need a scratch pad. Which power, we're calling power again. X, which is 2. X, which is 2, comma, y minus 1, which is 3. So now x is 2 and y is 2. Oh, I have to hint it again. This is awful. Yeah, I need a scratch pad to do this. Fill in the blanks to calculate the expression x times x plus 1 using an anonymous function and call it for the number 6. Oh, Lord. Okay, I know that anonymous function is the lambdas. So a equals parentheses lambdas, lambda, lambda, x colon x. To calculate the expression x times x plus 1. So I need to put the times there. And call it for the number 6. Okay, so that should work. And it does. Fill in the blanks to leave only even numbers in the list. So we start off with our list, 1, 2, 8, 3, and 7. We will set this to the variable called res, short for result. Result equals list, because we want this to be an output in list form. We want to leave only the even numbers. I'm going to guess that filter is my keyword again, my function. And then I'm making a lambda expression, so I have to write lambda x colon x modulo 2 equals 0, comma num. So then we print rest. Let's see if I'm right. And goody. Drag and drop from the options below to print only the items in the set A that are not in set B. Only A that are not in B. Print A minus B. Yeah. Okay, that ended the functional programming quiz. The next video will be over object-oriented programming for Python 3.